let's first find the extrema of this. To find the extrema, the first thing you need to do is find the derivative. This right here is a product rule. Derivative of x is 1. Leave e to the negative x. Plus, leave the x. And when you derive this, you get e to the negative x, as well as derive the power. Derivative of this is actually negative 1. So that looks like the derivative, which would be e to the negative x. Because do both of these have e to the negative x?
Yeah.
Actually, let's wait on that. And then this negative would be minus x e to the negative x. So that's the derivative, which could also be written as e to the negative x, because there's a GCF, 1 minus x. So these are both derivatives, just different forms. Okay, I think this would be easier to do my second derivative of when we go to point of inflection, but this one's easier to solve for critical numbers. Okay, now let's just do my second derivative right away before we even deal with extremas or points of inflections. So my second derivative, I'm going to focus in on this one right here. E to the negative x by itself will become negative 1 e to the negative x, because again, you derive this one, you derive it and then derive the exponent. Okay. And when you derive this, minus, well, didn't we just derive this earlier? Got it? So isn't, when you derive this, how do I say it? This right here, isn't this right here just this whole thing? So can I just take this whole thing and replace it? So the derivative of this right here is the whole thing of itself, because it's kind of nice to look at your previous problem to help you out. And so that is your second derivative, but from here you want to kind of simplify it down so that you can then make it so you can find your points of inflections. But let's see. These two can combine. Does that look like negative 2 e to the negative x minus x e to the negative x? Does that look right? Oh, not minus. Wouldn't this be plus? Because this minus distributes. Is that right? I think so. And then we have now e to the negative x, GCF, is 2. Is that a negative 2? It's a negative 2. So it would be negative 2 plus x. Okay, let's see if I missed anything. Does that look okay?
Yeah.
Distributes. Hopefully that's right. It makes me feel like I'm missing something. We will see here in a second. If we set the top equal to 0, I think I've missed something, but we'll see. 1 minus x, set that equal to 0. These are our critical numbers. Now, when you set this equal to 0, does it have any values? Could you ever have a number to a power and get 0? No. So this would be none for this one. But when you have 1 minus x equals 0, what does that give us? That would be you minus it over, divide by negative 1. Want to be a positive 1? Now, can we plug 1 to here? Does it exist? Yeah. What is f of 1? Won't that be 1 times e to the negative 1, which is 1 over e? Is that 1 over e? Now, that coordinate would be 1 comma 1 over e. Is that a max or min?
Yeah.
We have to plug this in, good, to the second derivative. Instead of doing the first derivative test, let's do the second derivative test. So if we plug it into, which one? Doesn't matter. Let's just do this one right here. And when we plug that in to the second derivative, so you do f double prime 1. When you plug that in, let's see what we get here. Let me see. I'm just thinking something real quick. Oh, we're good. Okay, when I plug that in, we got a negative 2 e to the negative first plus 1 e to the negative first. And when you do that, all you care is if it's positive or negative. Well, isn't this going to be a fraction of some sort? And this be a fraction? So you've got negative 2 over e plus 1 over e. Does that look right? Which would be, isn't this going to be negative? Or just negative 1 over e is what it's going to be. It's negative, so that since it's negative, it's concave down, so it is a max. A relative max. A relative max. Now, from there, that's our relative max. Now we got to find our points of inflections, so we're going to set this little bad boy equal to 0. And when we do that, do I have to set the front equal to 0? I already did it here. I told myself it doesn't work. So I can ignore the first piece. When I set the second piece equal to 0, what do you get? Well, you're going to get x equals 2. Now to get the coordinate, we're going to do f of 2. And when you do f of 2, that would be 2e to the negative 2 power, which is 2 over e squared. So my coordinate is 2 comma 2 over e squared. Now, you might think that is a point of inflection. If a coordinate exists, what do you have to check to make sure it's a point of inflection? You have to actually make sure it changes concavity. So let's actually check that. If we're at 2, let's see if it changes from positive, negative, or negative to positive. So what's an easy number to plug in? Let's try 1. If you plug 1 into this, didn't we already do that out here? And when we plugged it in, didn't we get a, what, negative? So wasn't it negative right here, what we previously checked? Let's plug in 3. So f double prime 3, when we plug that in, well, let's just look at this one. If I plug in 3, that would be 1 over e to the third. So would this be positive when I plug in 3? Will this piece be positive? Yes. And what's negative 2 plus 3? Is that positive? So a positive times a positive, that's actually a positive. Okay, so you got f double prime 1 is negative, f double prime 3 is positive. It changes concavity, so we can verify it's actually a point of inflection. You want to always verify it. Most of the time it's going to be, but not always. So this is a point of inflection. Hopefully that makes sense.